Okay, hello guys, and welcome to the first video lesson. As I explained last week, the idea is that we make a summary of the topics of the week throughout this video. You guys will be taking notes on your notebooks, and you will be completing the exercises that I will be doing also throughout the video. The idea is that you guys save those evidences on your notebooks, and then you take a picture and upload that evidence to Google Classroom. Remember that the idea is that you work with one video per lesson. Now, this topic throughout the week is going to be related to fractions, so we will talk about the representation of fractions, fraction of amounts, and also operations with fractions. As I said when I explained last week the way in which we're going to work, the idea is that you guys take your time, you can watch the video, solve the exercises, and then at the very end of the class, upload pictures so you can prove that you were working on the corresponding assignment. So let's begin. Now, general information about the video itself. Please be sure to watch the complete video. I do not recommend you skip parts of the video because if not, you will be lost. But you are allowed to pause the video or go back at any time needed, especially if you want to redo an exercise or if you want to re-watch a section of the video. Now, the video includes exercises, so if you would like, you can pause the video, solve the exercise, and then wait for me to show the answer. Also, remember that other people will be watching the video at the same time, so please be mindful about time and space with your classmates. People will be working at different paces. And also, ask questions. There are people around you, maybe with the same question that you have, or maybe a person around you already knows the answer. So try to connect with people around you to solve questions that you might have. And finally, remember that you have to upload pictures of your work. So I highly recommend that you take notes of the lesson itself, that you have the information on your notebook, so then you can upload the picture and show me that you were working throughout the lesson. Let's begin. Okay, the first thing we're going to do is to discuss equivalent fractions. I'm almost sure you guys did this previously on year 5. The idea here is just to point out that there are different ways in which you can write down a fraction, and if the same fraction can be written down in different ways, that means that there are several equivalent fractions associated to the number. So let's use this bar model that you see there on the screen as a reference. For example, in the upper part, we have a rectangle or a bar that has been divided in 5 parts. But the same bar was divided in 10 parts. So what we have here, is that the same bar model has 2 different ways of being divided. You can divide it in 5 parts, so the section itself has this size. This is one of those 5 parts. Or if you want to cut in more parts, then you can use, in this case, a smaller section. And 10 of those makes the full bar. So now the question is there any way you can find equivalent representations of the same values? For example, if I join 2 of those small sections, that creates one of the ones on top. So what I can say here is that 1/5 is the same as having 2 of those 10s. Let me repeat, that 1/5, this one on top, is the same as having 2 of the red ones, okay? So that means that those two expressions are equivalent. Now, if you want to find this answer quickly, what you have to do is, let me erase this. We have a 2 here. Okay, so if you want to find the solution quickly, the only thing you have to do is multiply this one. Multiply that expression by 2 and the one below by 2 also. So technically what we're doing is that we're multiplying each one of those numbers by 2. So for example, 1 times 2 is 2 and 5 times 2 is 2. I'm sorry, 10. So once again, the diagram is very useful. 1/5 is exactly the same as 2/10, given that 2 of those will fit exactly in 1 of the fifths. Let's continue. Let's see if we can find another equivalent expression. So let's erase this one over here. Okay. So we have the solution already. And on top we have 5 parts. Below we have 10 parts. Let's continue with the next one. Now they're asking us to group 8 of the green one. So we have 1, 2, 3, 4, 5, 6, 7, 8. So then 8 of those is exactly the same as having 1, 2, 3, 4 of those fifths. So we can write it down here, right? That 4 out of those 5 elements will give you 8 out of 10. Once again, take a look that if you multiply by 2, 4 becomes an 8, and 5 times 2, it becomes a 10. So the best way to find an equivalent fraction is by only multiplying by the same number on the numerator and denominator. Let's create a new exercise for ourselves. Let's imagine that we don't need all those. We can only stay with a section of it. So let's imagine I'm choosing 2 of those fifths, and the question is how many tens will that be? So I'm choosing 2 of those fifths, and the question is how many tens can I fill with it? It's 4 of them. Or if you guys would like to amplify this a little bit more, you can erase this, and let's add an extra one, for example this one, and then these 2. So let's count again. That means that if you collect 3 of those fifths, then that will be 6 of the little ones. Okay. Once again, the whole idea is that you guys identify equivalent fractions. We can create more. There's many more options, but for now, the idea is that you guys remember exactly how to find equivalent fractions. And in this case, the technique is quite clear. You have to multiply by the same number. For example, here, you multiply by 2, and you multiply by 2 down here. Okay, perfect. So once again, that is the technique. Now let's see if we can solve a few exercises now without using the bar model. The bar model is just a reference, but we should be able to solve exercise without it. For example, in this case, there's no more bar model available. What we want to do is to find some equivalent fractions, but only by using the multiplication option, not using a diagram. So for example, let's imagine you guys start with 1/2 and you would like to amplify this by 3. erase. Let's multiply this by 3. Okay. Perfect. So remember that if you're going to multiply to find the equivalent fraction, you need to be sure that you multiply both the numerator and denominator. In this case, I'm multiplying 1 by 3. That gives me a 3 on top. And then 2 times 3, that gives us a 6. So that means that 1/2 is the same as 3/6. Let's do the same with 3/4. What I can do in this case is that I can multiply by 5 each one. And don't forget that the number we're using is 3/4. So in this case, 3 times 5 is 15. And 4 times 5 is 20. Okay, perfect. So now in any case, take a look that I'm choosing random numbers that I'm using for multiplication. The only thing is that you have to be sure that you're multiplying by the same number, numerator and denominator. Let me repeat. Let's use this one as a reference. If you want to find any expression that is equivalent to the one I have here, in this case 3/4, then you have to multiply by the same number both in the numerator and denominator. So in this case, it's multiplying by 5 both. So 3 times 5 is 15 and 4 times 5 is 20. That means that 15/20 is equivalent to 3/4. And quickly enough, because we don't have more time, I can, let's do this one very quickly. We have 4/5. And for this case, we can multiply by any number we want. We can multiply by 4, for example. If we do that, then 4 times 4 is 16. And 5 times 4 is 20. So we're saying that 16/20 is exactly the same as 4/5. And then finally, the last one, that is the easiest one because both numbers are the same. So when you divide 10 by 10, the answer is always 1. But if you multiply by 2 on both expressions, we can find an equivalent representation of 20/20. And that one is important because it's the full whole. We can say 5/5, 6/6, or like in this case, 10/10. And that makes a big difference, especially because you can find many numbers associated that are equivalent. Okay. So with this, let me close this. I just want to remind you guys, when we talk about equivalent fractions, the best technique to do this is just multiplying by the same number, both the numerator and denominator. We'll come back to that technique in the future, but this is also a good way to do it. Okay. Now, as part of this introduction, in the same way we did this with decimal numbers and whole numbers, you should be able to find fractions on the number line. Let's do this one very quickly. I don't want to extend myself too much. This is just a quick review for you guys. So an arrow shows 1/2 of the number line. So in this case, I have to draw the arrow exactly in the middle. So what we can say is that exactly in the middle is this one. So we should have 1/2 exactly in the middle of the number line. Why do I know 1/2 is exactly in the middle? There's several ways you can explain that. For example, that 1/2 is the middle distance exactly. It's the middle of the number line, so you just find which is the number in the middle. Or the second way is that 1/2 means that you have to split the complete number line in two, and that the expression exactly in the middle is the one that you need. So in this case, 1/2 is the one representing that. And then finally, in terms of 3/10, for you to be able to locate 3/10, you need 10 parts. This has been divided in 10 parts already. So you have all the way from 1 to 10, you only need 3. So what we're going to say is that the fraction should go here. So this is 3/10. It is important for you guys to recognize the position of fractions, but also for you guys to be able to locate them in the correct location. Now, to do that, you can count the amount of spaces, you can verify that you have the total amount required, or also you can use equivalent expressions. That's perfectly fine. Okay, so this is in terms of locating those two fractions on the number line. We have 3/10 and 1/2. And this is something that also applies for any other fractions. For example, in this case, 9/10, we know that this is almost the unit, almost, but it's a little bit behind that final position. So it's 9/10. So there's one more space, 1/10, that separates 9/10 over 1. But afterwards, they are proposing a new expression, in this case 11/10. The interesting thing about this is that the numerator is bigger than the denominator, meaning that you can change that into a mixed number. So we can transform 11/10 as 1 and 1/10. And that makes a big difference because now on the number line we only have a space for 1. But now they're asking us to add a new expression. 11/10. Now, why is this important? Because fractions sometimes represent numbers that are smaller than 1. But in some cases, the fraction can be larger than 1, especially when the numerator is larger than the denominator. So you should be able to identify the position even when the number line doesn't have that space for you to find the location of 11/10. So you should be creative enough to identify that the number is larger than 1, so you can locate that on the correct position. Okay, so let's review very quickly. We were talking at the beginning about how to find equivalent fractions, how you can locate them by using a bar model, or now that we were working directly with fractions, you can find equivalent expressions by just multiplying the same number, both the numerator and denominator. And finally, when we're investing a few minutes on locating fractions on the number line, especially important that in some cases the fraction can be a mixed number, so you will have to locate the number over 1. Once again, those are numbers that are larger than 1. Okay. And to finish with this first video lesson, I would like to talk about improper fractions and mixed numbers. Those were already present in the previous exercise, but this is a very, very good time right now to discuss their location on the number line. So for example, for the first one, we can see that they're asking you to locate 8/5. And what we know about that is that 8 is larger than the 5, so it should fit 1 complete time and then 3/5 is over. So it's 1 full and 3/5. So if this is a grid that is already divided in groups of 5, then that means that we can locate this number directly. So we have a full 1, that's the one in yellow, and then 3 more. And that will be the position of the number. So this is 8 out of 5. So let me repeat. In some cases, you will have to change the improper into mixed to locate them on the number line, or completely upside down. You start with the mixed number and then you will have to write it down as an improper fraction. So let's make the change. In this case, we have 2 2/3. Erase. Okay, let's see if it works. There we go. Okay, 2 2/3. So the first thing is to take a look that the line is separated in groups of 3. And that is positive because we have to fill in 2 full groups. So we have the first 6 spaces, they reflect 1 complete round. So that means that we have 2 units in total and then 2/3 afterward. So 2 more out of the 3. And in this position, this is where that number is located. It's 2 2/3 or 8/3. And that's it. So once again, it's all about showing that you guys know what you're doing. Once again, that you show that you've worked with fractions in the past, and especially in this time of the year in which we're moving super fast, that you have your notes complete on your notebook. So as part of this video lesson, you have to show that you were working on the numbers, that you were drawing the number lines, that you were working the examples with me. So please be sure to include them on your notes. Now, what's coming next, because that's important for our following lesson. We will be comparing fractions, so we will be able to see if one fraction is bigger than the other. And as we compare, we're going to use different techniques, either equivalent expressions or bar models. And then as we finish that, we're going to move towards fractions of amounts. It's a very interesting exercise to be solved, and then we're going to do some sessions individually. Okay, for now, then let's close up with the general idea. I've given you guys the instructions of the video lesson. We started by identifying different types of equivalent fractions, and we discussed the technique of multiplying both the numerator and denominator by the same number to find an equivalent expression. And then finally started locating fractions in the number line, especially the special case in which the number that you're supposed to locate is larger than 1, and that's perfectly fine. That is a possibility. Okay, and that was the last exercise for this video lesson. So what we're gonna do afterwards, in this case is on your next lesson, is comparing fractions. And then after we compare, we immediately jump into fraction of an amount. This one is a very nice topic to be covered with now that we're making the introduction to fractions. Okay, perfect. I'm gonna leave that for the next class. For now, remember, you have to finish your notes, you have to write down the examples, and then afterwards, take a picture and upload on the assignment so I